Okay, let's try one example of using a Riemann sum to evaluate an integral. Let's say we have an integral like the integral from 2 to 4 of x squared plus 1 dx. That is to say, we want to know what is the area under the curve. Oh, let's see, 1, 2, 3, 4. X squared plus 1 at 4 goes up to what? 17. It's a parabola that goes like this. And we want this area, the area from 2 up to 4. Can I highlight it in? We want to add up this area. So what do? We use the Riemann sum. We say that this is equal to, well, let's use the general formula because I want you to have this memorized. The limit as n goes to infinity of, what is it, b minus a over n times the sum I equals 1 up to n of f of a plus I b minus a over n. That is to say, what is b? b is 4, a is 2, n, well, n is n, and f of x is x squared plus 1. So what do we have? We have the limit as n goes to infinity of 4 minus 2 over n. That is to say that the whole width is 4 minus 2. It's 2 units across, and if we chop it up into n different pieces, each one is 2 nths wide. And we add up I equals 1 up to n of, well, let's hold off on the f for a second. A is 2, 2 plus I, and again, b minus a over n is 2 over n. And so what happens? We plug this into our function. So we have the limit as n goes to infinity of 2 over n times the summation I equals 1 up to n. We want to square this thing and then add 1 to it. So it's 2 plus 2i over n squared plus 1. Can I do it up here? Okay, whatever. So, we want to add all of this up. Well, now it's just a matter of algebra. The limit as n goes to infinity of 2 over n summation I equals 1 up to n of. We square this thing. Hopefully you remember how to do this. 2 squared is 4. It's going to be, remember that this is 2 plus 2i over n times 2 plus 2i over n. So there's the 2 squared. Then you have 4i over n plus 4i over n is 8i over n. Plus that last one squared, which is what? 4i squared over n squared plus 1. And the 1 plus the 4 is 5. And again, so the 1 and the 4 make that 5. And this is a summation of things added up. We can add them up separately. We can call this the limit as n goes to infinity of 2 over n of 3 different summations. We have the summation I equals 1 up to n of just 5, plus the summation I equals 1 up to n of 8i over n, plus the summation I equals 1 up to n of 4i squared over n squared. Now some of these aren't so bad to figure out. This is the limit as n goes to infinity of 2 over n times what? Well, we add up 5 plus 5 plus 5 plus 5 n times. We get 5 times n. Now what is this? We add up 8 times 1 over n plus 8 times 2 over n. Well, we can take the 8 over n's out of all of that, and then we just have the summation of I. That is 1 plus 2 plus 3 plus 4 plus 5 up to n. And that we figured out is n times n plus 1 over 2. What Gauss did in elementary school. And this one, we can take the 4n squared out. because as far as this is concerned, the n is a constant. The limit over here, n is becoming a very, very large number, so we have to hold off on that. But I squared, the I is changing. We can't pull the I squared out because sometimes it's 1, and then it's 2, and then it's 3, up until it's n. And that, according to the formula that I didn't prove, was n times n plus 1 times 2n plus 1 all over 6. But now we have no sigmas. Yay! And what do? Now we can do more algebra and simplify all of this out. As n goes to infinity, I suppose I'm going to multiply this 2 over n times everything. Well, what can cancel out? There's an n down here and an n up there. There is... well, what have we got? 2 over n times 5n. The n's are going to cancel out. It's just going to be 10. 2 over n times 8n plus 1 all over 2. Well, those 2's are going to go away. Can't cancel out too much more at this moment. Over here, again, we multiply the 2 over n in front, and then we have the 4 over n squared. Then we have this whole mess. N times n plus 1 times 2n plus 1 all over 6. However, what we have is n is going to infinity. This is a limit at infinity. Well, certainly, if n goes to infinity, 10 is just going to be 10. That's what it is. But over here, we have what? We have a limit. Well, we can add these things separately. Basically, as n goes to infinity, we have what's the highest thing up top? It's like 8n. What's the high, 8n plus 8 over n. But it's basically like 8n over n, because that plus 8 stops meaning something when n becomes a billion, a trillion, a quadrillion. And then over here we have what? 8 over n cubed. What is the coefficient? Skip it. What is the coefficient? What is the highest power of n up top? We're going to have n times 2n is 2n cubed. 2n cubed times this 8 is 16n cubed plus smaller stuff. And then down below we have 6n cubed. And these come out quite nicely. Because of the limit as n going to infinity, these go away and we are left with 10 plus 8 plus, let's see, 8/3. Which is, what is that? 18 plus 8/3 is 2 2/3, or 20 2/3. What is 20 2/3? That is, oh really? I'll draw it again then. 20 2/3 is the integral from 2 to 4 of x squared plus 1 dx. It is the area under the curve. This is y equals x squared plus 1 from 2 up to 4, this area. Now this is not the easiest or the nicest way to do things, but we found the area of a not very nice shape. It's curved. It's a parabola on the top. We're not talking triangles. Some people say, oh, it looks kind of like a triangle. Well, it's not a triangle. It's different than a triangle. It's curved on top. And yet we have found the exact area under that curve using the Riemann sum formula. The Riemann sum formula, which I want you to remember.